Alright, it says number 17 to 21. State the transformations necessary to create the given function. Alright, again, with this stuff, the first thing you always need to ask, step 1, is it inside or is it outside? Okay, remember inside is x, it's backwards, it's the opposite. That is your left and right, that is your horizontal. Okay, if you are outside, you deal with y variables, and it is normal. So that's your up and down axis. That is your vertical. Okay. Once you figure that out, you just say, hey, that's question 1. Question 2, am I adding, subtracting, multiplying, or dividing? Or did I simply make something negative? Okay. And here are your options. You can, if you are for a shift, you are adding or subtracting. For a stretch or shrink, you are multiplying or dividing. Again, remember, just because you're multiplying does not mean you're stretching, because the inside is backwards. Last but not least, a reflection means you multiplied by a negative or divided by a negative. So, like this one down here, you're multiplying by a negative 1/5. That's a reflection. That deals with that is either a stretch or a shrink. Okay. However, that is a subtraction sign, so that is not a reflection. Okay. Cool. So here we go. Number 17. Question number 1: is it inside or outside? Well, it's outside, so it's vertical and it's normal. So if we're adding 2, it is simply a shift up 2, because that's what makes it go up. Because it's outside, it's y, it's normal, so your only options are up and down. Positive y is up. Alright, if you're in the absolute value bars and you're adding 4, okay, inside is x and backwards. Inside is x and backwards, so you can only go left or right. And it's backwards. So normally x is positive, but really, since we're in backwards land, positive is to the left. So it's just shift left 4. Alright. Number 19, we got 2 things up there. Okay. We're going, we got a negative 3 on the inside, and we got a positive 2 on the outside. Okay. So this one's outside, and we're subtracting. So subtracting is normally to the left, but inside we're backwards, so we're really going to the right. So that is a shift right 3. And on the outside, okay, outside is y. And you do exactly what it says. Your y's are up and down. So you're going up. So the shift right 3 and up 2. Okay? Number 20. Feel free to pause anytime you want to stop. But I'm just going to keep going. You've got 3 things going on there. You've got the 2 out front, you got the negative 1, and you got the positive 3. So I'm going to start with the minus 1 on the inside. Again, if you're subtracting, you are shifting. And a negative minus 1 is normally to the left. But since we're inside, we're backwards. So we're really going to the right. So there's a shift right 1. And this one out here, okay, outside, that's your first question, in or out. That's outside, so it's y values, and it's normal, so it goes up. Shift right 1 and up 3. Last but not least, this 2 out front. That 2 out front, you are multiplying. There's nothing in between there. It's butt up against it. So that is multiplying. It's outside, so it's vertical. So there's a vertical stretch, because making it bigger, normal is stretching by 2. Right. And not last but not least, number 20. Number 20 has three things going on, okay? You've got this negative out front, you got the 1/5 out front, you got the 1/2 out front, okay? And remember, with all fractions, the top part multiplies and the bottom part divides, okay? But again, I'm going to start on the inside. Right? That's it, because that's just how I do it. I just think on the inside first. So inside, remember that's x and backwards, so that's left and right. So if you are a 1/2, this means you're dividing by 2. If you are dividing by 2, you are, in a normal case, you will be shrinking. But you're inside. So in reality, this is a stretch. So this is a horizontal because it's inside. Stretch by 2. Okay. And this is the reason I'm going to put two fractions on here. Outside, we've got two things going on here. First things first, you got this 1/5, but up against it, there's nothing in between here, so you're multiplying that fraction. But fractions, top multiplies, bottom divides. So we are in vertical world. And when you divide, you get smaller, right? So in normal cases, where we are outside, you shrink. Vertical, shrink by 5. I intentionally put this problem up there because I wanted to show that just because you're dividing, this one is a stretch, this one is a shrink because of its inside or outside. You gotta start with the question inside or outside. Alright, last but not least, this negative out front. Okay? If you are multiplying by a negative, that is a reflection. So this is reflection, reflection across the... Alright, so it's outside, you would think y, but this is really across the x-axis. Here's y. Here's my graph. Outside is vertical, right? Outside is your up and down. So if I am reflecting up and down, I am crossing the x-axis, not the y. Because the statement doesn't say, hey, it's in the x direction. No, the statement says I'm going across the x. And across the x, that is a vertical action. Okay? So reflections might feel backwards, but that's just how they are. All right, last one on this page. Number 21. 2/3 x minus 5 squared. I'll start with the inside. Again, you're subtracting on the inside. So normally you think subtract means go left, but really in backwards world it means go right. So this is a shift right 5. All right, and this one out here, I'll put this one on there specifically because remember, this is multiplying right here because it's butt up against it, and it's outside, so it's vertical. All right. The last but not least, this is actually two things going on here. You are stretching because the 2 multiplies and shrinking, so you can state it that way. You could say it is a vertical stretch by 2 and a vertical, you know what, I'm going to say vertical stretch by 2 and shrink by 3. Or you could sum it up in one, say it is a vertical, because 2/3, if you multiply by 2/3, think of it this way. If you multiply by 2/3, are you getting bigger or are you getting smaller? This is 0.6666666. So it's actually getting smaller. So you could say that is because it's smaller than 1, you could say that's a vertical shrink by 2/3. Alright? And that would get the same point across, but in one statement. Alright, but oftentimes I find it easier for students to think, well, 2/3, well, the top multiplies, bottom divides. But whatever works for you.